So, good afternoon or good evening as you prefer. First of all, thank you for inviting me to this important event. I wish you a really successful project. Hydrotech is a regional project funded by the Puglia region within the framework of European Regional Development Funds. So within this project, the objective is to put together scientific institutions as they are Ispa, National Research Council of Bari, and SIAM, the Agronomic Institute of Bari, and two small and medium enterprises, they are SISMAN and the Directra Lab. SISMAN is the coordinator of this project. Hydrotech promotes the concept of eco-efficiency. Eco-efficiency is a concept that is a standpoint of Horizon 2020 program of European Union, and within this concept the objective is to decouple resources used from economic growth and environmental impact from resources use. So the objective is to get as much as possible from economic point of view that you can see here, and to use as less as possible of resources in terms of water, in terms of land, in terms of energy, in terms of emission of CO2. So this means we have to think how to integrate inside the project objective of farmer who needs to produce as much as possible and to get high economic benefit, and of water manager that would prefer to have maximum water productivity that is given here. In terms of irrigation district, this means that we have on one side to integrate best agronomic practices at different farms to arrive to the district scale, and then to transfer this information to the engineering aspects of water management that should deliver water to different farms on the most efficient way. So, if we are going to use some formulas, we can say that we should always think how to apply the best agronomic processes in order to reduce agronomic demand, and on another side to think how to increase as much as possible irrigation efficiency. That is mainly a topic that should be managed by engineers. So we try to put all those things inside a Hydrotech project. That is a project that should integrate and automate different tools in order to be used first at farm scale, and we hope also later on at the district scale. So inside we have on-field devices, weather stations and other sensors, and irrigation system, of course, with the wells, user that can use tablet devices or smart phones in order to receive information about irrigation. And on another side that we have application part, so server and the models that are going to interact with the whole system. All interaction is going through data cloud. That is the concept that is used to explain with the message broker that implement those applications through a common external interface. So this is the way how you can see the architecture of agriculture, of the Hydrotech project. The main features of the project, we can say, there are many of them. We try to combine crop and soil water status monitoring using the sensors and water balance modeling. We apply multi-model for estimation of reference evapotranspiration that depends on data availability. We try to adjust whenever possible RS, so KRS, that is the coefficient of solar radiation, and crop coefficient to local condition. We are going to apply different types of crop development models. One that is running through the days and another that is applying growing degree days. And here is concept. Then we try to use also multi-crop response to water model. So the function proposed by Stuart and also the function proposed by Rao. We have inside also weather forecasting data for the next 3 days. And we try also to completely or partially automate the level of the applications on the farm. So this is a real-time remote management tool that could be applied for one or several crops altogether. So the objective is to allow optimization on water management, integrating different dynamic management strategies for different crops and for different fields. So we need one farm or one farmer that is going at the same time to manage several crops and have to optimize water use for them. And of course, this is always a tool that could be improved according to the feedback that is coming from the user, so from the farmers. This is the data flow of the project. On one side we have data acquisition, then elaboration of data, a repository of all databases, model engine, the first one that is running soil-water balance. This is a deterministic model, and another one that is using forecasting data for modeling balance for the future dates. Then we have a sort of dynamic optimizer, what is the best time and volume of water to be applied. And after irrigation, that is given here, all data are registered and we are going back into analysis for another days. Here is given the, calculation module of irrigation schedule, part of the model. So climatic data are going inside the weather data module for estimation of reference evapotranspiration. Then we are going to run soil balance on the basis of soil data and crop data, and we are going to estimate irrigation input using also the management limitations. So we can be used inside also several methods to improve estimation of reference evapotranspiration and crop coefficient. So we apply also correction of KC values to local climate and crop characteristics that is related to local values of relative humidity and crop height. We apply also for orchards correction based upon the fraction of ground cover by vegetation and its height that is embedded here and it is published here. We are going also to apply a multi-stage model for estimation of KC, and also we are going to use data that are coming from the latest experimental works that are done in this region. This is an example for seed propagated globe artichoke recently done and published in Bari. We are working at 9 farms applying our product on 10 crops and 20 experimental plots. Here you can see some of the locations and the name of the crops that we are using. Let me show you in brief some examples of field units. Here you see the weather data, and here also sensor soil sensors that are connected to wireless radio data logger. This is a product of direct lab device. This is the name of Hacienda where we are going to apply. You can see this is the case of Banyar. Another example, soil motion sensors connected to wireless data logger. These are decagon devices. They are always applied. You see at 2 depths we have shallow and deep sensor. Why we are going to have different sensors? Because this is the way that we can go to manage if amount of water that we are applying is regular, it is excessive, or we are going to go under deficit. So we are going to combine the data coming from shallow sensor and those that are coming from deep sensor. So you think in this case it means that we are under deficit, in this case we are applying too many water, and this is something that should be a regular way of application. So we are going to consider it in our work. And this is another type of devices that is based on the wireless radio data loggers. This is developed by ETJ Devices. This is a company from Florence region. In this case, they are applying a sort of sensors that are able to monitor all data use at the hydrant scale, and also through this type of sensor we can also activate hydrant and open it in order to allow water flow through it and irrigation. This is one of the latest achievements of technology in this sector, because it allows us to work also in the marginal area where there is no connection of mobile telephones. And here you see there are some technical supports that is always necessary to be provided for the farmers, because we go directly to farmers to design in our database how their irrigation system was implemented on the ground, what is the distance between rows of different crops, what is the distance within the row, what is the flow of emitters that are going to be used in that particular case. And of course we are going to advise them how to use tablet on the best possible way. There are two ways that our user can assess the system. One way is through the web application. So through the web application they go, enter inside the system. This is a farmer, one of them. You see he has different crops. Here you see there is a meteo station. This is his farm, and there are some other locations in which we have sensors that are used in this farm. And he can go and understand what is the actual situation that is related to soil water content and how situation will progress in the future. So we are also providing the forecasting data, what will happen. So you see in this particular case that probably 3 days from today our crop could be somehow under water stress. Here we are going to also show other variables, that is here the trend of reference evapotranspiration and crop evapotranspiration, and here you can see also the soil water depletion, how it is progressing in respect to threshold that is readily available water. Sensitivity to water stress we try to regulate at different geological stages. And this is one example in which I would like to show you using the coefficient of water stress here. So we have this initial phase, no stress between bud burst and flowering. This is the case of peach. And then in the second of wine, and this is the moderate stress until varization phase that we are going to allow, and after that for the final period we are going to increase stress approaching the fruit maturity and harvesting. Another example that is related to peach tree, no stress between flowering and pit hardening. So during the first stage, here we are going to show you the graph using soil moisture variability. The second phase, we can allow moderate stress during vegetation development, then no stress during fruit development, and finally we can allow moderate stress during post-harvesting phase. So these are just two examples that we can apply when we are going to manage irrigation. Example of mobile Android application. Here you will see the main screen that will appear in the case if you are going to use a mobile. Red means that here we have to irrigate, while green is an indication that our crop is under optimal water conditions. Of course, inside you have data that are related to last irrigation, and also where should be done the next irrigation, the data related to last precipitation, and so on. On other screens you can see also soil moisture variation during the season, and you can see also on the next screen the meteorological variables. So you see here the data about minimum and maximum temperature, and the temperature and the humidity data, and so on. And here, these are the data that are related to different sensors that are installed directly in the field of farmer. So, here is one of the farms that we are managing, that is located close to Taranto, and they are producing vineyards, you can see. And here is the website through which you can access the system, and in the case if you provide to you the username and password, you can also enter inside and manage the data somehow. So this is all I would like to say. Thank you for your attention.
Aspetta.